Welcome back. Today we will be solving lead code problem number 543, diameter of binary tree using bottom-up recursion. This is also one of the popular FANG question as of October 2024. Let's go through the question. Given the root of a binary tree, return length of the diameter of the tree. The diameter of a binary tree is length of longest path between any two nodes in a tree. This path may or may not pass through the root. The length of a path between two nodes is represented by number of edges between them. Let's look at the example 1. So this is the tree and output is 3. This is because 3 is length of path from node 4 to node 3 and the number of edges are 3, which is this. Let's understand the question using this example test case and think about the solution. The expected output will be 5 because length of longest path is from node 10 to node 70. The number of nodes are 6 but the number of edges are 5, hence 5 is the output. The observations are longest path is between leaf node 10 and leaf node 70, which is 5. When taking node 40 as root node, then we observe the longest path becomes sum of height of left branch and height of right branch. Longest path has to be between two leaf nodes. The intuition based on these observations are that for each node, we need to calculate the height of its left branch and the height of its right branch. And then we need to calculate the diameter passing through this node, which will be the sum of height of left branch and height of right branch. This question is a tree problem. Most of the tree and graph problems have solution DFS and BFS. We will use DFS using recursion with bottom-up approach to solve this problem. In the tree DFS traversal, it is divided into pre-order, in-order and post-order. We will specifically use post-order where we will explore left node and then right node and then we'll do some calculation, which is the diameter calculation using the current node. Let's visualize the solution. We will start the DFS post-order tree traversal from root node 20. From here we will go to left node 40. From here we will go to left node 50. There is nothing on left side, so we will go to right node 10. This is a leaf node. We don't have left or right side to go to. So now we will calculate the diameter with current node being the root node, which will be the sum of left branch height and right branch height, which is 0. Because this is a bottom-up approach, we need to return something to the parent node. The return value will represent the height of the current sub-branch of the parent node, which will be 1 plus max of left height, right height. In the return value, this 1 is because of we are adding the current node to the height of the sub-branch. And we are adding the max of left height and right height to maximize the diameter that the parent node will be part of. We will go to the parent node 50. Similarly, we will calculate diameter with current node 50 being root, which will be sum of left branch and right branch, which is 1. The value that we return to the parent node will be 2. Next, we will go to parent node 40. We did not explore the right branch of node 40. As part of post order, now we will explore the right side, node 60. We will go to node 10 at right. We will go to node 70 at right. Now we have reached the leaf node. We don't have left or right to go to. So we will calculate the diameter with current node 70 being root, which will be 0. The value that we return to the parent node will be 1. We'll go to the parent node 10. The diameter of current node 10 being root will be sum of left branch and right branch, which is 1. The value that we return to the parent node will be 2. Next we will go to the parent node 60. Diameter of current node 60 being root will be 2. The value that we return to the parent node will be 3. Next we will go to parent node 40. Diameter of current node 40 being root will be sum of left branch and right branch, which is 5. The value that we return to the parent node will be 4. Next we will go to parent node 20. Diameter of current node 20 being root will be sum of left branch and right branch, which is 4. This node does not have any parent node, so we can ignore calculating the return value and we will stop our tree traversal. So the diameters of each node being root is this. And we pick the maximum of all the diameters, which is 5, and return it. Let's look at the code of the solution. First we will initialize max diameter to 0. Next we will call this nested recursive function. Inside the function we have our base case where if node is none then we return the height as 0. Next we recursively calculate the height of the left branch of the current node. Then we recursively calculate the height of the right branch of the current node. We calculate the diameter with current node being the root, which is sum of left branch height and right branch height. We keep track of max diameter seen so far. We compute the return value of the parent node, which would represent the height of the current sub-branch. Then finally we return the max diameter. Let's do a complexity analysis of our code. The time complexity will be O of n, where n is number of nodes in the tree. This is because we have to visit all the nodes in the tree to compute the longest diameter. The space complexity will be O of n. This is because of the space taken by recursion call stack, which relates to the height of the tree. And in the worst case, if the tree is skewed, the height of the tree will be O of n. Thank you for watching this video and stay tuned.